What's up, guys? In this video, I'm going to go over the properties of exponents, and how to execute them when things get messy. Because the basic rules of exponents are generally relatively simple, but when you start to get big monomials with multiple variables like 3xy times 4x squared times y cubed or stuff like that, it can get kind of messy when you have long terms like that. So uh, yeah, so first you want to make sure you have the basics down. So when you talk about the basic properties of exponents, so first thing, probably the first one you'll learn is multiplying. So let's say you have x squared times x cubed. Well, so when you multiply terms with exponents, all you have to do is add the exponents. So 2 times 2 plus 3 is 5. But you can only do this when you have like terms in the same basis. So we can do this because we have x and x. If we did this with y, we would have to do I don't know. If we had y cubed times y to the fourth, we would have to have both of them have to be y. So this would be y to the seventh. So we can't do x cubed times y to the fourth. We can't do that because we don't know what x and y are. So we can only do that because even though we don't know what x is in this case, we know it's the same number, so we can do that there. So always make sure you have the same base when you're performing this. So that's what you do for multiplication. And if you have division, let's say you have x to the seventh, moves down, x to the seventh over x to the third. What you have to do, well, since multiplying goes with adding the exponents, dividing, you could probably already guess it goes with subtracting. So 7 minus 3 would be 4, so x to the fourth. So if we did that with y to the eighth over y to the, third, this would be y to the fifth. And if we had parentheses, let's say you had x to the, x squared to the third. So this is not the same thing as x squared times x cubed. This is the same thing as x squared times x squared times x squared, because that's what cubed is. You're basically multiplying the number inside of that cube by itself 3 times. So using the multiplication rule, you can see 2 plus 2 plus 2 is 6, so x to the 6th. But the shortcut from this is if you have x squared to the third. So if you have that term and then you have an exponent outside the parentheses to that, then all you have to do is multiply the exponents. So 2 times 3 is 6. So this would be x to the 6th. And if you had, y to the 7th to the third, it'd be 7 times 3 is 21. So you would have y to the 21th. So then, okay, so yeah, that's basically how you want to look at it for the parentheses problems. Don't get mixed up between the multiplication and the parentheses. If it helps you, you can always write these out, like y to the 7th times y to the 7th times y to the 7th. But if you can grasp onto the shortcut rule right away, that's great. So, and the final main property would be the negative exponent. So if I give you x to the negative 2, well, the one thing in math you never want to do is have a negative exponent. And so to get rid of the negative exponent, you basically have to kind of flip it to the denominator. So if you can kind of write this over 1 because it's the same thing. You would have this would also be equal to 1 over x squared. So by flipping it over, you keep the same exponent, but it becomes positive. So if I gave you 1 over x to the negative 2, this is also the same thing as x squared, I guess, over 1, which is just x squared. So yeah, for example, if I gave you y to the negative 3, this would be 1 over y cubed. So those are the basic properties of exponents. I'm going to go over some of the long monomial ones so you can kind of get used to executing them. So let's say I gave you 3x cubed y squared times negative 4 times x to the fourth y cubed. So first thing you want to do is when you see like this kind of problem, first thing you want to do is match the like terms. So in this case, 3 matches with -4. X cubed matches with x to the fourth, and then y squared matches with y cubed. And so when you match them, you just want to kind of look at the property, what you're doing. So you're multiplying here. So you want to multiply the terms. So 3 times -4 is -12. X cubed times x to the fourth. Well, because you're multiplying exponents with the same base, you can just add the exponents. So 3 plus 4 is 7, so it's be x to the 7th. And then the y squared times y to the cubed, you add the exponents, so it'll be y to the 5th. And that's just your final answer. So again, first, you always want to be able to match up and organize your problems so you know what the exponents, the like terms are, and then you want to know what property you're doing. So it just helps you get organized. So let me give you a division one. Let's say -42 x 7y over 6x to the fourth y squared. So same thing, you want to match up the like terms. So -42 and 6, they're both numbers, no variables. Those are like terms. X to the 7th, x to the fourth, they're both x. And then y cubed and y squared match up. So same concept with the multiplication, you just want to divide the like terms. So -42 divided by 6, well, we know that's -7, so -7, x to the 7th divided by x to the fourth. The property of division for exponents is subtraction, so that would be 7 minus 4 is 3, so x to the third. And then y cubed minus y squared, 3 minus 2 is 1, so y to the 1, which is just y, so you don't even need to write that 1, so that would be your final answer for that. And then let's do a parentheses problem. Say 7x cubed y to the fourth to the third, let's say that. So here, let me not do 7. Let me do like 3. So same thing. So when it comes to, not the same thing necessarily, when it comes to the parentheses problems, it's kind of like a distribution, I guess. So what I mean by that is like, so you would have to cube everything in that, so all the terms. So you have to cube 3 x to the x cubed, and then y to the fourth. So 3 cubed would be 27. X cubed to the third. The property for the parentheses, for the exponent outside the parentheses, is multiplying. So this would be x. Let me do the color. X to the 9th, and then same thing for y to the fourth. 4 times 3 is 12, so it'd be y to the 12th. So that would be your final answer for that. And then it kind of gets messier with the negative exponents. So for example, if I gave you 2x fourth, x to the fourth, let me not do that. Let me just do x to the fourth times y to the third times z to the, I don't know, like negative squared or something like that. And then I'm multiplying this whole thing by, or not multiplying, the exponent on the whole parentheses is -3. So for now, ignore, like when you see negative exponents, I suggest you kind of wait for the last step before you kind of convert anything. Just kind of do the kind of your general property first. So for example, like in this one, the property for the parentheses, it would just be multiplying. So x to the fourth time to the -3, you just multiply -3 times 4, which would be x to the -12, and then y to the 3, y cubed to the -3, 3 times -3 is -9, and then z negative 2. So negative 2 times negative 3 is 6. So this would be your answer. But yeah, this is not your final answer. You have to simplify it further. So again, when you see negative exponents, you always want to get rid of them. So like I said before, you have to put them in the denominator. If the negative exponent is on a base that's in the numerator, you just have to flip it into the denominator. And if it's in the denominator, you have to put it to the numerator. So in this case, you have x to the negative 12 and y to the negative 9 in the numerator. So you have to put them to the denominator. So z to the 6 is already positive, so you don't need to worry about that. So is z to the 6 over x to the 12 times y to the 9th. And so that would be your final answer for that. Yeah, it can kind of get messy with the negative exponents, but I would say your main takeaway should be to know how to separate the like terms and kind of get yourself organized through that. And when you see negative exponents, like wait for the last step before you kind of split them and then put them in the denominator or like relocate them. So like in this one, you just want to be able to separate this from z to the 6th. So when you see these negative exponents, you can just put them in the denominator there. So all right, so I'm gonna give you kind of a big problem with basically everything that we went over. So you can pause the video and do this yourself. I'm gonna start doing it now. So we see in the numerator we have 2 times x to the negative 2 times y to the 4th, all raised to the power of negative 3. So just like we went over, the exponent kind of has a distributive property. So you'd have to do 2 to the negative 3. Even though you can calculate that, I suggest you keep that the way it is now. X, and you'll see why. So x to the negative 2 to the negative 3. So negative 2 times negative 3 is 6. So it becomes positive. And then y to the 4th to the negative 3. 4 times negative 3 is negative 12. So we have that numerator set. And then when we have the denominator, so for this one, because you're multiplying them, you have to look for the like terms. So 2 and 2 are like terms. X and x squared are like terms. And then y squared and y to the 4th are like terms. So then you have to multiply the like terms. So 2 times 2 is 4. X times x squared, you have to add the exponents. So it would be x to the 1 times x squared. So 1 plus 2 is 3. So x to the x cubed. And then y squared times y to the 4th. 2 plus 4 is 6. So y to the 6th. And so that's our denominator. So now we have the numerator and the denominator. So before we do anything else, there's 2 ways you can go about doing this. So you see the negative exponents. So what you could do is just take those negative exponents and put it in the denominator to make it positive. So this is probably the best way to do this one. So x cubed, x to the 6 is already positive. So you can kind of leave that the way it is. And then you would have 2 to the negative 3 times y to the negative 12 times this expression, which is 4x squared y to the 6th. And so when you multiply these, because when you put in the denominator, it should be positive. So this should be 2 cubed and then y to the 12. So 2 cubed, you can just make that 8. I suggest you do it here instead of doing it here, because if you did 2 to the negative 3 here, technically this would be like 1/8 basically. So like if you had 1/8 up here, it would get kind of confusing. So it's better if you leave this as 2 to the negative 3 until you kind of make the exponent positive. So this would be 8. And then here, let me put this x squared over 8. And then y to the 12th times y to the 6th. Since you can just add the exponent. So 12 plus 6 is 18. So y to the 18. And then the final step in this one is the division. We have x in the top, x in the bottom, so we just subtract the exponents. So 6 minus 3 is 3, so this would be x to the third all over y, 8 times y to the 18. So this would be your final answer for that. And yeah, so in this problem we went over all the steps that we went over. So yeah, good work.